Okay, this is the second part of section 2.4, and we were talking about factors in the last video, and we're going to just keep going with that and talk about finding all the factors of 24. So remember, you want to use your counting numbers. And remember, that's 1, 2, 3, 4, 5, 6, and so on. So let's start writing out the pairs. Two numbers that when you multiply them together will get you to 24. So easiest one, 1 times 24. I'm going to keep going with 2. 2 does go in. 2 times 12 is 24. 3 goes in. 3 times 8, I'm just keeping it going with the counting numbers. 4, I believe, goes in. 4 times 6. 5, does 5 go in? No. So we're back here to 6. So 6 goes in. It's right here. We already wrote it down. Does 7 go in? No. 8 goes in. We already wrote it down here. Does 9, 10, or 11 go in? No, but 12 does. We already have it here. So it looks like these are going to be all the factors of 24, because our last factor is 24 times 1, and in between 12 and 24, like 13, 14, 15, 16, and so on, all the way up to 24, none of those numbers go in. So none of those numbers are factors. So these are all my factors of 24. So I am going to list all the factors out. Remember, small to big. With commas. So if you want, you can just go down the first column and then come up the second column, and those will be how you're going to write out your factors. So from 4, I'm going to switch over to the second column and go 6, 8, 12, and 24. So these are all the factors of 24 listed out, and this list is what you're going to put in the answer box on your WebAssign homework. Okay. So that was a few examples of factors. Let's talk about prime and composite. Does anybody remember what a prime number is? Yes? No? Well, a prime number is a number that only has two factors, which are 1 and itself. So they only have, these numbers, these prime numbers only have two factors, 1 and itself. So if you take 7, 7 is a prime number. Would you know why? Well, the only two factors that 7 has is 7 and 1. 7 times 1 is 7. No other numbers can go into 7. 2 can't go in, 3 can't go in, 4 can't go in, 5 can't go in, 6 can't go in. So the only two factors for 7 are 1 and 7. So since it only has two factors, 7 is prime. Can we name some other prime numbers? What about 11? Does anything go into 11 but 1 and 11? Think about the counting numbers. 2, 3, 4, 5, 6, 7. Do any of those numbers go into 11? No. Just 11 and 1. What about 13? 13 is also prime because 1 times 13 or 1 and 13 are the only numbers that are factors or that go into 13. What about 17? 17 is also prime. So there's a bunch of different numbers, and I know you're looking at 11, 13, and 17, and you may be thinking, well, I know all odd numbers seem to be prime, because the ones I've done 7, 11, 13, 17. They are all odd. Well, you might think that, but I'm going to say look at 9. 9 is odd. Is 9 prime? Are there any other numbers besides 1 and 9 that will go into 9? Does 2 go in? Does 3 go in? Does 4 go in? Does 5 go in? Well, if you said 3, that, since 3 goes into prime, I'm sorry, I've been doing too many videos. So since 3 goes into 9, or since 3 times 3 equals 9, 9 is not prime. So 9 has more than two factors. One and 9 are factors, and 3 and 3 are factors. So 9 cannot be prime. So no, not all odd numbers are prime, and 9 puts the kibosh on it. So since 9 is not prime, we say in math that 9 is a composite. So 9 is not prime, it's a composite. So a composite is a number that has more than two factors. So if it's got 3 factors or 4 factors or however many factors over 2, then we say it's a composite. So 9 is a composite. And a prime only has 2 factors, 1 and itself. So how is that so far? Let's do some examples. Let's show some examples of composites. Okay. So we know that a composite has more than 2 factors. So can you give me another composite besides 9? Because we know 9 is a composite. Well, what about 10? Why is 10 a composite? Well, 1 times 10 is 10, but 2 goes in. So 2 times 5 is 10, so that makes it a composite. What about 14? Is 14 a composite? Well, 1 times 14 is 14. 2 goes into 14. 2 times 7 is 14. So since more than 1 and 14 go in, 14 is a composite. It has 4 factors, which is more than 2 factors. And what about 15? Is 15 a composite? Does 15 have more than 2 factors? Well, it has 1 times 1 and 15, or 1 times 15, but does it have anything else? Well, 3 goes in and 5 goes in. 3 times 5 is 15. So it has 4 factors, which is more than 2, so it is also a composite. And there's millions of composite numbers and there's millions of prime numbers. So they just go on forever, both of them. So I noticed in your homework on WebAssign, they're going to ask you if a certain number is prime or composite. So what about 27? Is 27 a prime number or a composite number? Well, 1 times 27 goes in. Okay. Does 2 go in? No. Does 3 go in? 3 times 9 is 27. So already I have 4 factors. So since I have 4 factors, I know it can't be prime. So we say 27 is a composite. Okay, let's do just one more. Is 29 a prime or composite? We know 1 times 29 is 29, so 1 and 29 are factors. But think about, can 2 go into 29, or 3, or 4, or 5, or 6, or 7, or 8? Are there any other numbers that you can think of that will go into 29 evenly with no remainder? If it just has 1 and 29 as factors, then it's a prime. And I don't think there are any other numbers that go in. So 29 is a prime, or a prime number, however you want to say it. So they're going to give you a number on WebAssign, and they're going to ask you if it's a prime or composite. And just think about the counting numbers and what numbers go in. And if there's more than 4 factors, it's a composite. If only 2 factors, being 1 in itself, go in, then it's a prime. So this is the end. No, I got one more section. Sorry about that. I've got one more section, which is 2.5, and then we'll be done with Chapter 2. So as always, if you have questions, send me an email.